we did this with the simplest example I can think of that's not trivial. I could have given you a straight line, but you can read off the gradient of a straight line without doing a derivative. Okay? Let's really quickly do, because I referred to it, let's do x cubed. Relax. You guys have done binomial. You'll be fine.
Do we have to put this underneath these two graphs?
Yeah. So you might need a new page. But this is as easy as binomial gets.
No, it is. That's
Oh,
not
yes, it is.
It is, right? It is.
Yes, it is.
Come on, binomial goes way up. Trust me.
I still don't do one.
X to the 17 divided by... No.
X to the 21.
Alright, so we're just giving x cubed a go. Now, just as we go through this, just have a mental image of what x cubed looks like. I drew it before, but it's not a difficult curve to imagine. Right? Let's do our first principles here. Right? The first thing I'm going to write after f dash is equal to the limit as h approaches 0, because I want the gradient of the tangent, not the secant. Right? Okay, now what's going to happen on the top? It's f of x plus h, right? X plus h cubed. That's f of x plus h, isn't it? And then here is f of x. Right? There's f of x plus h. There's f of x. And you divide by h, right? Which is that run which is getting smaller and smaller and smaller and smaller. Okay? Now, don't freak out. You've done binomial. You know how to expand this. Okay? There's the limit, because we're not figuring. Okay, I'll stop. I'll stop now. I promise. X plus h all cubed. What are the coefficients? Which row of Pascal's triangle am I after? 1, 3, 3, 1. Right? So I'm going to get 1, 3, 3, 1.
That would take me like
That's
2
it.
minutes.
Okay? 1, 3, 3, 1. You can see the powers of x, they climb down just as the powers of h climb up. There's f of x plus h, and of course I've got f of x tacking along on the end. All of that, don't forget, is divided through by h. Okay. And you can see, I've even still got it on the board, almost an identical thing happens on the numerator. You got this x cubed up the front and this minus x cubed at the back, right? And then what you get there, all of the terms on the top magically have an h in them, right? So let's factorize that out. H outside of. So get that? Yep. Okay, now we can cancel just like we did earlier. Okay, and all you get left with is this. Look, Mark, no denominator. So now I can actually put in, see what happens as h gets to 0, and all of these guys here, because they have h's in them, they vanish away. They become trivial, right? So all you get left with is this plus these guys, right? Which of course is 3x squared. All right, ready? You have that picture in your head of what x cubed looks like. Here it is. Wow, that's lucky. I'm not going to do that for the next 99 graphs, okay? I've got x cubed, right? 3x squared. It's this steep parabola here. Whoa, twice. Anyway, okay? Now, what's happening to this? Well, over here, right, the derivative, this is f dash, the derivative is positive. What does that correspond to? Over here? Increasing, increasing, increasing. Positive gradient, okay? Then the parabola, the derivative, comes down to 0. What does that correspond to?
Slowly curving.
Stationary point.
Stationary point. The gradient is 0 at the origin. And then my parabola just goes back the way it came and becomes positive again. So positive, 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 positive. Okay.
Wasn't it going down?
It wasn't going.
No, this side of the parabola was going down, right?
Now, please don't confuse. Now, this is a major point, okay? Major, major, major point. This is f dash, and this is f, okay? So you remember when we were thinking about regions before, and we were shading so you knew where the graph went and so on, okay? So the region that this goes to, the sign of this, matches the gradient of this. The sign of this matches the gradient of
So
this.
the gradient is decreasing.
Yeah, the sign of this, negative, matches the gradient of this, right? Now, people get confused because they look at this and they're like, That's not positive. It's negative. It's below the axis, right? We're thinking of gradient. That's what my plus signs are.
But the
Right?
gradient is decreasing, so why do you write plus?
The gradient is decreasing, but it's positive. It's positive.
It's a positive.
See that?
What?
It's an increasing function. It's going up.
Right?
Right? So if you test a value here
But then it's
and a value here, the second one will be higher. So it's an increasing function. It's going up.
So even though it's at a decreasing rate.
It's slowing down.
slowing down.
It's slowing down, but it's still positive. It's still heading in that same direction, right? Just like if I were running and then I slowed down. I'm still going in the same direction.
still running.
No, you're
Right?
stationary.
Now I'm stationary.